Have you wondered what causes rainbows? But more importantly, why is it that you always see red on the top and the blue on the bottom of the rainbow? And secondly, why is it that you always see rainbow in the direction of the shadow? Always. It means you need to always look in the opposite direction of the sun to see a rainbow. Why is that? Let's find the answers to these. To understand rainbows, we need to shine white light on, say, a medium and see what happens. You probably know when light goes from rarer to denser medium, it'll bend towards the normal. However, white light is made up of all the colors of the rainbow, right? And it turns out different colors bend different amounts. It turns out that the red color will bend the least. Look, it's not bending much compared to the initial direction. And the blue color bends the most. And all the other colors in between bend in between. This phenomena, where different colors bend differently and therefore they split when refraction happens, is called dispersion. And you can now guess that dispersion is one of the main reasons why we see colors in the rainbow. But wait a second. You may be wondering, well, if dispersion happens here, shouldn't dispersion happen everywhere? For example, when you see sunlight through a glass window, why don't we see colorations? Because dispersion should happen there as well, right? Well, that's a great question. But to answer that question, let's look at a glass window a little bit more carefully. So you see, the edges of the sides of the glass window are parallel sided. What happens when you shine white light on a parallel sided glass slab? Well, just like before, you do see dispersion. White light splits. However, here, the rays of light bend towards the normal, just like we saw before. But now when they're exiting, they're going from denser to rarer medium, the ray of light will bend away from the normal. And so look at what happened. Here, the light bent down, and then when it exits, the light bent back up. And therefore, finally, when the colors exit, they all become parallel to the incident direction. All the colors become parallel to each other. So what? So what happens if the colors become parallel, you ask? Well, if you now look at all these colors, these parallel colors, then your eye lens will focus them all at a single point. Remember, all parallel rays get focused at a single point on your retina, and therefore you will see white light. This is the reason why when you're looking at the sunlight through glass slab, your window pane, because they have parallel sides, even though dispersion is happening, inside the glass slab, you don't see the colorations anywhere. So that means we now have the question, what if the sides are not parallel? Then what happens? Well, let's look at them. A typical example is a prism. Again, let's shine the light. You can see the rays of light are bending towards the normal, just like before. And now when they exit, this time the rays of light will bend away from the normal, but look carefully. Even though the rays of light are bending away from the normal, here again they bend down. So you see, the first time the rays of light bent down, but because now the other side is not parallel, this time again they end up bending a little bit more down. And so now you can see the colors are no longer parallel. They are getting separated, unlike what we saw here. So this time when you look at the colors, you will be able to see them distinctly. An example of this is when you shine light through diamond, you can see the colors. So when you shine light through a non-parallel sided glass slab, like for example a prism, not only do you get dispersion, but you actually see the coloration coming out. This coloration is what we call the spectrum. So you see in a prism you have dispersion and a spectrum, but in window panes and glass slab you have the dispersion, but you don't see the spectrum because the colors don't separate out. Okay, now that we have that basics, let's see what happens in a rainbow. So for a rainbow, you need a raindrop. And you can see raindrops don't have parallel sided glass. They are not parallel sided because they are curved, and therefore you also have dispersion and the spectrum coming here. Now let's look at it carefully. When white light enters, it splits, and again, I'm only showing two colors, but you'll have all the colors in between. And just like before, these rays of light, these colors will go out of the other side. But for rainbows, we are not interested in the light that goes out. Most of the light actually does go out. But a small portion of the light actually reflects back and comes out from this direction. This is the light that's responsible for seeing the rainbow. Now, immediately you might say that, wait a second, the blue is on the top and the red is on the bottom. So shouldn't we see blue on the top of the rainbow and the red on the bottom of the rainbow? Not really, because you don't get to, all the colors from a single raindrop does not reach your eye. Here's what I mean. Look at this drawing. So if you look at the top raindrop, you can see only the red of that is entering your eye. The blue is missing it. But if you look at the bottom raindrop, its blue color is entering your eye and the red is missing it. And so now, when you look at the raindrops, this raindrop appears red to you, this raindrop appears blue to you. And of course, all the raindrops in between will appear different colors. And this is the reason why you see the red is on the top and the blue is in the bottom. This also explains why you need to always look at the rainbow in the opposite direction of the sun. Because look, you have to, because the rainbows come due to the reflection of the sunlight. And so in order to see the reflection of the sunlight, you have to see in the opposite direction. Look at this, sun should be here somewhere, its light will get reflected and then comes towards you. So by understanding dispersion, we can also understand what causes the colorations of the rainbows, why the red is on the top, and why you always see rainbow in the opposite direction of the sunlight.